Introduction to the periodic table. The periodic table of elements is like a map of all the known chemical elements. Each element is a substance that cannot be broken down into simpler substances by chemical means. The periodic table arranges these elements in a way that shows patterns in their properties. Structure of the periodic table elements and atomic number. Each element has a unique number, called the atomic number, which represents the number of protons in its nucleus. The atomic number is usually written above the element's symbol. For example, hydrogen, H, has an atomic number of 1, meaning it has 1 proton. Groups and periods. The table is organized into columns called groups and rows called periods. Groups, elements in the same group, vertical column, have similar chemical properties. For example, the elements in group 1, known as the alkali metals, like lithium, sodium, and potassium, are highly reactive. Periods, elements in the same period, horizontal row, have the same number of electron shells. As you move from left to right across a period, the elements become less metallic. Element symbols. Each element is represented by a 1 or 2 letter symbol. The first letter is always capitalized, and if there is a second letter, it is lowercase. For example, carbon is represented as C and helium as He. Understanding element categories. The periodic table is divided into several categories based on element properties. Metals, found on the left side and the middle of the table. Characteristics, shiny, good conductors of heat and electricity, malleable and ductile. Examples, iron, Fe, copper, Cu, and gold, Au. Nonmetals, found on the right side of the table. Characteristics, not shiny, poor conductors, brittle when solid. Examples, oxygen, O, carbon, C, and sulfur, S. Metalloids, found along a zigzag line between metals and nonmetals. Characteristics, have properties of both metals and nonmetals. Examples, silicon, Si, and boron, B. Noble gases, found in group 18. Characteristics, colorless, odorless, and extremely unreactive. Examples, helium, He, neon, Ni, and argon, R. Halogens, found in group 17. Characteristics, very reactive, especially with alkali metals. Examples, fluorine, F, chlorine, Cl, and iodine, I. How to use the periodic table predicting element properties. By knowing the group and period, you can predict an element's properties. For example, elements in the same group as sodium, like potassium, will react similarly with water. Electron configuration. The position of an element can tell you how its electrons are arranged. For instance, elements in group 1 have 1 electron in their outer shell, making them very reactive. Understanding reactivity. Reactivity tends to increase as you move down a group in metals and decrease for nonmetals. Identifying trends. Atomic size. As you move down a group, atoms get larger because they have more electron shells. Across a period, atoms get smaller as the increasing number of protons pulls the electrons closer. Electronegativity. This is the ability of an atom to attract electrons. It increases across a period and decreases down a group. Ionization energy, the energy required to remove an electron. It increases across a period and decreases down a group. Conclusion. The periodic table is an essential tool in chemistry. It organizes elements based on their properties and shows trends that help us predict how elements will behave. By understanding how to read and interpret the periodic table, you can unlock a deeper understanding of chemistry and the behavior of matter.